Hello student, we see again this one is a 5.2. There's a refraction of light. So I want to do the revision for this one topic. Okay, from this one video script, what we will learn? We learn about the explain the refraction of the light. Okay, then we need to show about the diagram of the light ray passing through the glass block, incident ray, normal light, and also refracted ray. Okay, after that we will show about the incident angle and also the refracted angle. Okay, 3, we define about the angle incident and also the angle refraction. Okay, number 4, we need to draw the light ray. Okay, when they just travel from the less than to denser, or you reverse from the denser to the less than, and also third one, parallel to the normal line. Okay, what happened to the speed of the light, and also the compare about the I and also the R. Okay, then we go and see number 5. You need to state about the law of refraction of the light. So from here, we need to learn about the 5 of the item here. Okay, let's start now. Okay, first one, we're going to see the refraction of the light. Okay, the direction and also the speed of the light that will change. Okay, change in the velocity when they cross about the boundary between two material with the different density. So from here, the example, different density means from A, they go to the glass block. So these two medium is a different density. So from this one situation, we call it as a refraction of the light. Okay, from this one situation, refraction of the light, the speed and also the direction, they will changes. Okay, let me see the first diagram. Okay, the first diagram is from the A to O. Okay, A to O is the same medium. Okay, so this one they mentioned, this one is a denser medium. Okay, when they go from the O to B, this one situation is a less than medium. Okay, what you can see. Okay, first one, we draw the normal line at the center. Normal line must be 90 degree with the boundary. Okay, now you go and see. When I just hit to the O, okay, after the O should be different medium, is it? We go to less than medium. When I go to less than medium, you find the arrow that bend away from the normal. So from here, if I never bend, there should be straight line. Okay, should be the straight line. Okay, I draw now. I show about the straight line. If I never bend, should be the straight line like this. Okay, now I got bending. My bending is bent away from the normal. So I clear. Okay, when I'm bending away from the normal, can you see it? This one R. This angle R, we call it refracted angle. There's a more bigger compared to the incident angle. Okay, now we go to reverse. Okay, the second situation is travel from the less dense, go to denser. Okay, from A to O incident ray. Okay, when I hit to the surface of the O, okay, they need to bend. How to bend it? They bend towards normal. Okay, when they go to denser, you find it they bend towards normal. So this one is a situation you need to know. Okay, I conclude again. When they go denser to less than, they will bend away from the normal. When they go from the less than to denser, they will bend towards normal. So if they bend towards normal, you find it incident angle will bigger than the refracted angle. Okay, now we go to introduce. O, the line, what's the name? Okay, A to O, we call it as a incident ray. O to B, we call it as a refracted ray. Then the ON stand for normal line. I is the angle of incident. Then the R is the angle of refraction. Okay, now we go through the everyone explanation. Okay, angle of incident, there's an I. Okay, what means of the I? There's an angle between the incident ray and also the normal. Okay, R is an angle between the refracted ray and also the normal. So remember, both also must be between the normal line. Okay, I bigger than R. What situation they bigger than R? When the ray they bend towards normal. So that means there's a from less than to denser. So you find it, the I will bigger than the R because they bend towards normal, and also the speed of the light decreases. So that means when the light travel in the denser medium, you find it the speed becomes slowed down. Okay, if I reverse, angle of refractor, they're bigger than the I. Okay, what's the meaning? So this one means the ray now they bend away from the normal. Away from the normal means from denser, they go to the less dense. So the speed of the light now is increasing. Okay, so the way of the light ray can be traveled through the two medium. First one, A. When the light ray they travel from the less dense to the denser medium, okay, the light ray is refracted towards normal. So normally sometimes we say bend. So for this one topic, because of the refraction, so we're using the word refracted towards normal. Speed of the light decreases. So when the light ray they travel from the denser to the less dense. So this one we call it as a light ray is refracted away from the normal. So the speed of the light decreases. Okay, so third one should be no anchor. So when you see this one diagram, when the light ray is incident normal, they're exactly same like the normal line on the boundary between the two medium. So we find it the direction should be the same, straightforward. But how about the speed? The speed sure changes because you travel from the two different medium and also density changes. But this one, the light ray should not be bent. They just go straight. Okay, so from here, this one is an overall diagram. If I combine all just now together, so incident, okay, after that they're refracted. Okay, refracted inside the denser medium, there's a glass. Okay, after that, when they want to go out again, they will refracted again. So this one is a refracted away. Okay, so this one you call it incident angle, this one refracted angle. Normally, we never count this part. Okay, we count incident and refracted is starting part. Okay, this one is a final part. So final part, we never count. This one is a refracted angle. This one is an incident angle. So we just say the first part is the incident and also the refracted. Unless you go to separate. Unless you go to separate, so I can say this one incident, another one is a refracted. Okay. Okay, now we go to law of refraction. Okay, when the light they travel from one medium to another medium, there has a different optical density. So the first law, incident ray, refracted ray, and also the normal, they all must lie at the same point. Okay, we cannot say same point, there's a same line. So all the point of the incident all will lie at the same plane. Okay, one of the plane, okay, after that they all will meet at the same point and also same plane. Okay, the second law, there's a Snell law. Okay, Snell law is a formula. The formula should be the sine I over sine R. So the I should be the incident, then the R should be the refractor. Okay, one of the things you need to know for this one formula, the I, sine I must be happen in the vacuum. So remember just now the diagram, the incident from the A, they go to the glass block. Okay, after that from the glass block, they want to go out, is it? So from here, you must remember when they want to go out, okay, outside they want sure is a I, incident angle, because I say already incident I must be happen in the A. Okay, so later we see the calculation, then we know what happened for this one situation. I say the I must happen in the vacuum. Okay, now we're going to see this one formula, sine I over sine R. Later you get the value should be the constant number. So this one constant number, we call it refractive index. So you're using the N. Okay, how about the unit? Sine I over sine R suppose no unit. So they just one constant number only. Okay, now we're going to see the refractive index is what characteristic. Okay, first one, N is a refractive index, I is an incident angle, medium less denser. Okay, they must travel from the medium less dense. R must be denser medium. Okay, this one is a fix already. The I must happen in the less dense, R is denser. Okay, now you see the N, refractive index of what characteristic? A material with the higher refractive index, the meaning is higher density. So if I say glass and water, so sure your answer must be the glass is high refractive index because there's a density high. Okay, number two, refractive index must more or equal 1. So that means later you do the calculation, refractive index cannot get 0 point something. That one is wrong already. Okay, minimum your answer must be 1. then the rest must be more than 1. That one is a refractive index. Okay, last one, refractive index is a no unit. Okay, so this one is a 3 thing you need to know about the refractive index. Okay, now we need to answer the question. Okay, by referring the diagram on the right, now you need to calculate the refractive index of the liquid X. Okay, we need to do the calculation by using the Snell law. Remember Snell law? Okay, now we apply. Okay, remember I told you incident angle must happen in the less than medium. So this one should be the incident angle lah, 60. This one is a refracted angle. So I just write about the formula. Okay, N equal sine I over sine R. So I straightforward put sine 60 over the sine 30. Okay, so I press the calculator and get the answer. From here, I get the answer is a 1.732. Okay, if the answer got so many decimal points, so better you get 4 significant figure. Okay, then we go to the example 2. Example 2, they want you to draw. Draw on the diagram below. Okay, after that, approximate the direct of the refracted of the ray. Okay, so from here, we need to see where they travel. From the less than medium to denser. So less than to denser, I should be bent to towards normal, is it? Okay, now I show first. This one is never bent. Agree. If I never bend, should be the straight line pass through the denser medium. Now I need to bend towards. So sure I know this location. Okay, another location sure wrong already. Here is nothing. Cannot show here. So must be show this part. Okay, now I need to bend towards normal. Okay, how will towards depends for yours. You cannot say, oh, I'm mixed. I'm a 20 degree, I'm a 30 degree. No, the question never fixed. So from here, you just show the line you are closer to the normal. So this one we call it as a refracted. Okay, where's the incident? This one is a incident angle. Okay, then we go to second question. Okay, second question is from this one is a denser. Okay, denser, they go to the less dense. Okay, denser go to the less dense, we must bend away, is it? Okay, so I show the normal. Okay, this one is a normal if I never bend. So now you need to show far away, is it? Bend away. So you show bend away lah. So how big you go to bend is up to you. So this one we call R. Okay, this one still I. Okay, so this one we call it incident angle and refracted angle travel in 2 different medium. Okay, we go to the next one. Okay, example 3. Example 3 diagram they show about the ray of the light. They're moving from the A to the liquid A. Okay, from A to liquid A means less than to denser. So you forget, you just label every time. Okay, you just label less dense. Okay, sorry. So correct. So this one should be the less dense. Okay, this one is a less dense. This one is a denser. So that means when you want to find the refractive index, we need to find it. Incident angle is how many? So sorry, this one not incident angle. Many students they confused for this one diagram. They just see the 30, they will take it. This one not incident angle. Incident angle must be here. Okay, so we take 90 minus 30. This one is a 60. So now I do the calculation. Sine 60 over the sine 45. So I get a refractive index. So my refractive index here, the answer is 1.2. Okay, 1.2. So this one is my answer for the refractive index. Okay, now we're going to show another example here. Okay, this one is a sample of the question. We're going to see what's the problem. Okay, let's see the first one. From the denser medium. The blue color is a denser medium. Okay, they travel After that, they go out. Okay, outside should be the A. So that means now the light ray is travel from the denser to less than. Okay, denser to less than. So you will assume this one incident, no? Agree, because they start first. Incident, refracted. So I do the calculation. Okay, sine 36 over sine 55. Okay, I do the calculation. Finally, I get the answer. 0.72. Is it correct or not? The answer should be wrong, because I told you refractive index must more than 1. Okay, so if you see this one situation, what you need to do, you need to reverse. Okay, you need to reverse the anchor. Okay, so from here they say the value of the n must greater than 1, then the sine I must happen in the vacuum. Okay, so you just go to reverse the anchor only. Okay, sine I become 55. The refracted angle become 36. So we just take sine 55 over sine 36. So your answer 1.39. So this one is more than 1. So if more than 1 means okay lah, that one is a refractive index. Okay, so B that told you already, light is passing from the A into the medium, and hence the direction of the travel of the ray must be reversed. Okay, if you find a situation like this, you need to reverse by yourself. Okay, the next one, we need to go to item number 6. Okay, item number 6, you need to describe about the experiment, okay, to determine the refractive index of the glass. So from here, what is the direction of the light when they travel A to glass? B, what happened to the anchor, incident and refracted? Okay, C, you state the relationship for the sine I and sine R. Then you need to sketch about the graph. Okay, E, you need to name the value of the equivalent to the gradient of the graph. Okay, deduce a Snell law based on the gradient of the graph. Okay, 7, you need to define the refractive index. Number 8, refractive index relate to the speed of the light. So from here, from the experiment, we need to answer all the things like this lah. So we go through. Okay, this one is the experiment 1. Okay, the aim, I want to investigate relationship between the anchor incident, anchor refracted. So remember just now what we learned, anchor incident refracted. If you travel less than to denser, incident must be bigger. Okay, refracted must be smaller. For this one experiment, what we can control, we just can control is the incident angle. Refracted angle we cannot control because they pass through the medium. Okay, we cannot control what happened. So now we see the variable. MV, manipulate variable, is the anchor incident. Refracted should be the responding should be the refracted. Okay, constant variable must be the refractive index of the glass block. So the glass block, you cannot change it, you must put there. You cannot say type of the glass block. Type is not accepted. So we just write the refractive index of the glass block, because different glass block, you got different refractive index. Okay, refractive index must be constant. If you change, that means all the changes. Okay, now we see the apparatus. We're using glass block, power supply, protractor, ray box. Ray box is this one. Okay, after that with the single slit, meter rule, and also a piece of the paper. Okay, the diagram set up like this. Outside is a white paper. Okay, center they put one of the glass block. Okay, this one is a ray box. The ray must be point to one of the boundary between the glass block and also the paper. Okay, let's see how to start the experiment. Okay, so from here the experiment they start, they place a glass block on the paper. Okay, trace the outline of the glass block, remove the glass block and draw a normal through the point Q. So you draw, okay, the glass block is here, you draw one of the rectangle. Okay, after that remove the glass block, then you label, this one should be the Q. Okay, using the protractor, okay, construct the several angle of the incident, I equal 30. So the first one you must mention manipulate variable the marks. Okay, procedure got 3 marks. So the first one you mention 30 degree means you get 1 marks already because you set the manipulate variable. Okay, number 3, you need to replace a glass block back to the paper. Okay, then switch on the ray. Okay, and direct the ray light at the Q along the line draw so that the angle of the incident is 30. So you mark 30 already. So from here you point your ray box. to the line, what you mark it, 30°. Okay, now you mark the path of the emergent ray at the W with the two crosses X. Okay, so when you just point the ray box here, they show the line hit to the Q. Okay, after that, in the glass block, they will refract it. Okay, we cannot draw because the glass block already block it. So from here, you will find it another ray that will come up from the glass block. Okay, this point. When it touch the glass block and it won't come out, so you just point this one as a W. Okay, now you got 2 points already. One is a Q, another one is a W. Now you go to remove your glass block, you go and draw the line. Okay, draw the line Q and also W. Okay, the glass block no use already, take out. Okay, now you remove the glass block, you join the two closest, that's a straight line until they touch to the outline of the glass block, that's a W. Okay, draw the path of the refracted ray by joining the point Q and W. So when you join Q and W, now you need to measure should be the incident angle you set by yourself, that's a 30. Then you need to find is a refracted angle. Okay, you find the refracted angle how many? Because you mark it already, use your protractor to measure. So number 4 they call, this one should be number 5. Number 5, you need to measure and record the angle of the refraction. Okay, number 6, you need to repeat the experiment. Remember, repeat experiment. Okay, you need to repeat, minimum is a 4 set. So just now you're using 30, now you're using 40, 50, 60, and also 70. Okay, this one is one of the example. Okay, very fast, so please observe. Okay, let's see the diagram. Okay, I want you to observe is the incident angle and also refracted angle. Okay. Okay, where we start? Okay, let's see here. Okay, we start from this part. This one is an incident, this one is a refracted. Okay, so I travel. So I set the angle here. So we start. Okay, can you see my angle is a 15? Okay, I set 15. Okay, when they just refracted, you find it. This one just 10 only. So that means the angle becomes smaller. Okay, now I increase my incident again until 20. Okay, 20 something lah. So you find it this one. Okay, they go to 15. Okay, I know incident angle increase, refracted angle also increase. Agree? So that means this part will bigger, then the refracted angle becomes smaller. Okay, so we see the whole video. Okay, I repeat, incident bigger, refracted also bigger. Okay, so from here we go and tabulate the data already. Okay, here I show you one of the data, although you never do the experiment. Okay, this one is an example. From there you how to label. Okay, because the ray just come out, you put the X. Okay, then after that you join the X. That means you put the sign here. Okay, after the join, then you go to measure the refracted angle. Okay, this one is a table from the experiment result. Okay, incident you set by yourself. Then the R is a refracted angle. Then the rest you need to do the calculation. Okay, press your calculator and get the answer. Okay, after that you need to plot the graph lah. Okay, then we go to discussion. Okay, what is the direction of the light ray when they travel from the A to glass? Okay, you find it the direction must be bent towards normal. Agree? So we check the answer. Okay, they're refracted towards the normal line. Okay, then we go to the second one. Okay, what can you say about the angle of refraction R when the angle of incident I increases? So just now I proved for you already. When the incident I increases, what happens for the R? The answer should be also increasing. Okay, we check the answer. The bigger of the incident angle, this one I think wrong already, not the smaller. So the answer should be, okay, I change again. The answer both also increase. The bigger the incident angle, then the bigger the refracted angle. Both also increasing. Okay, on the graph, you need to draw the graph for the sine I against the sine R. Okay, we can see the answer here. They show the graph. They also plot already. Okay, this one is a graph. They already plot. Okay, so from here, you need to calculate the gradient of the graph. Okay, so from here gradient, normally we find one of the point. Okay, one of the point we can read exactly. Another one, you need to draw the triangle must be big enough. Okay, big enough means 4 times 3 bigger. Okay, your triangle must be 4 times 3. What means of 4 times 3? This one is 1, 2, 3. Okay, this one is a 4. 1, 2, 3, 4. Okay, this one called 4 boxes. This one called 3. You want horizontal 3, vertical 4 also can. You want to reverse also can. So from here, let's check what they draw about triangle. Okay, the triangle must be drawn exactly, can read at the point. Okay, they set here. So you're going to find this point. So this point, we find it, there's a 0.96. Okay, so this one is 0.8. So we do the calculation. If they start from 0 with straight line to come down. So I get it, the gradient is a 1.2. Now, they will ask about what's the unit. Suppose this one is no unit. If you go to write the unit, then your answer should be wrong. So from here, I get 1.2, that's all. If they don't have any decimal point, that's all. You just write 1.2. Okay, so from here, we do the discussion. Okay, so from here, based on the graph, you need to state the relationship for the sine I and sine R. So from here, I get it, they pass through the origin, is it? So the answer should be directly proportional. So sine I is directly proportional to the sine R. Okay, state one of the precaution. So precaution, everybody know. For one of the precaution, then you can apply for any experiment. So the answer is, to prevent the parallax error, then your eyes must perpendicular. Hello, remember there's a perpendicular, not parallel. Okay, to the scale of the protractor reading. Okay, remember must have the scale and also the apparatus. We're using what apparatus? Protractor. Okay, conclusion. A graph of the sine I against the sine R is a straight line and also the pass through the origin. So this one is a conclusion from this experiment. Okay, after we finish the refractive index from the just now formula, the Snell law, now we need to introduce another formula. Also can find the refractive index that's from the velocity of the light. Okay, now the light that travel different in the different medium, is it? Just now we mentioned already the velocity will changes. Okay, light travel is in a high speed. There's a 3 times 10 power of 8. This one is a vacuum. This one is the fastest already. There's a in the vacuum, or you can say in the air. This one is the speed of light. Okay, this one is a constant number. Okay, B. When the light ray, they just passes from the air or they from the vacuum into the medium, is denser, the speed will reduce. So this one you also know, when they pass through the denser medium, they sure become slow down. Okay, now we can prove again another formula. N equals C over B. And we know refractive index, C is a speed of the light, okay, in the vacuum. Okay, B, speed of the light in the medium. So from this one the formula, sure you can get the N is more than 1 because C is the biggest. Okay, then the speed of light, remember, this one should be constant. 3 times 10 power of 8. Now we go to the example 4. There's a velocity of the light in the medium. Okay, this one is one of the question, the diagram that show about the ray of the light that passing from the glass block to the air. Okay, so now they want to find the refractive index of the glass. Okay, 1.54 already given. Okay, now a light ray that's a travel from the glass to the air. So the refractive index of the glass already provided. Okay, and also speed of light is provided. So from here we need to do the calculation. Okay, let's see here the first one, A. They want to find the angle of the refraction. This one is the incident angle. Okay, if we got about the refractive index, so we just can using the formula for the Snell law. Okay, if we want to find the angle, so we just apply. Okay, 1.54 is an N. equals sine data, because we don't know the data, though this one is a sine 33. Okay, so from here you need to get the answer by using the 1.54 multiply the sine 33. So after that you get the answer should be in decimal point, but final answer they don't want decimal point, you need to convert become angle. So from here you do a calculation, final you can get the answer is 57 degree. Okay, this one is a. Now we go to B, the speed of the light in the glass. Okay, we also using the same thing, speed of the light in the glass, 1.54 is a refractive index. Okay, for this one formula, the speed, we need to using the formula C over V. So we know the C is how many? 3 times 10 power of 8. Okay, then over the V. So your answer should be, you find the V lah. V equal how many? So from here, I get the answer is, okay, at blue. Okay, the answer is 1.95 times 10 power of 8 ms negative 1. So this one is the speed of the light when they go in the medium. Okay, so this one is a 2 of the question, also find refractive index, just the different formula we need to apply. Okay, then we go and see. Okay, this one should be the another question. There's a structure. Okay, we check it. Is it what they ask about that? Okay, first, if I draw the normal line, okay, I want to draw the normal line here. Okay, okay, and after I draw the normal line, you can see clear already. This one is incident, then this one refracted, is it? Can you see this one refracted away from the normal? If they're refracted away from the normal, this one angle become bigger. So for, I know medium A sure is a less dense. B should be denser. So this one situation will happen. So they ask you which one medium is A. So the answer should be medium A. Okay, medium A sure is a A already because there's a less than. Okay, B. Which one medium? The speed of the light should be higher. Sure is a medium A lah, the speed is higher. So why? Why they become higher? First one, they are less than. Okay, because there's a less than, then the light that go faster. Okay, they refracted away from the normal, then will go faster. Okay, let's see the answer. Medium A sure is a speed of the light faster. Reason is because there's a less than. Okay, after that, they will refracted away from the normal. So this one's a reason why the light ray at the medium A, they will go faster. Okay, then we go to the calculation. Okay, this one is a calculation. They want the refractive index also, refractive index for the medium X. So we just apply the snail law lah, because they give you both of the angle. So first one, there's a sine 45, because this one is a A. Then over sine 40. Okay, so from here we see what's the answer. Okay, from here I get the answer is 1.10. No unit. Refractive index, there's a no unit, and also there's a more than 1. So this one should be the answer. Okay, so we just discussed until here. Then the following I will upload soon. Okay, thank you for your watching.